Our final session of the day is Education and Workforce Development. My name is Michael Twydale. I'm at the School of Information Sciences at the University of Illinois, and I'm director of our new Master of Science in Information Management, which has now been going for just over a year. So I'm here very much to learn what we should be doing and how to do it better. And we've got a great panel to help me, and I hope also the rest of you in the audience will help out. Our plan is to invite each of our panelists to do a brief sort of position statement, 5 to 10 minutes of their perspective on workforce development. And then we've got plenty of time for question and answer. I've got some questions that I want to know, so anytime people don't put their hands up, I'll work through my list. And I will ask each of our panelists when they're presenting to start off by introducing themselves. So let's start off with Dr. Renata Rawlings-Goss. Take it away, Renata.
Good morning. Thank you, Mike. Can everyone hear me? See my slides?
Yes, loud and clear.
Perfect. So to introduce myself, I'm Dr. Renata Rawlings-Goss. I'm the co-executive director for the South Big Data Hub, which is a companion to the Midwest Big Data Hub. They're there for now. My background in big data is in computational genomics and genetics, and then I worked inside in the front office with Chiton and Fenn at NSF with the Big Data Research Program, as well as Big Data Policy around the Federal Strategic Plan for Big Data. And then with the White House Office of Science and Technology at the time, that was I started a program looking at data science meetup groups and organizations and how this effort around education that's non-traditional can affect social good and can be used for the benefit of the United States and bringing those people together. So someone mentioned earlier about models and how the different hubs may be different in models. So just briefly, the South Hub is the 16 states, Delaware to Texas, and we have a different model. Now we have two executive directors. I'm at Georgia Tech, and they have another executive director, Leah Shanley, at UNC. And today, I'm really talking about our education and workforce working group that I'm chairing, but these are all of our other priority areas for the South, which are a little more fluid and also slightly different from the Midwest priority areas. So for me, data science, education, and workforce, this working group is really about building data literacy as well as data science capacity through education, training, and workforce development. Because for the working group and in my looking out, I also run the director for industry partners for Georgia Tech Data Science, and we talk to a lot of industry about what they need. And it's really a problem of scale, which I think we all know, that there's just not enough people trained in a way that can accommodate the workforce you really need. And so that scale problem comes in a lot of different facets. So the working group does different programs and projects are housed under the working group, as well as kind of strategic direction, which is around four focus areas: institutional outreach, faculty and student development, workforce landscape, and resource development. So some of the things on this list are ways of getting at those goals. So first is surveying the educational landscape. So before I even started at the Hub, I was working with the SIZE AC committee and putting together a list of data science educational programs across the country and looking at different sources and websites that are cataloging those, and did a little bit of text mining around where those programs were housed and what types of departments they were in. So you can see, based on the visualization, I wanted to visualize geographically where those were, and you can see a concentration around the coast. When there's so much industry, there's a member of our advisory board that really talks about every company, no matter if they make shoes or supercomputers, is now a data science company in some way, in some fashion. And an argument can be made for cybersecurity as well. So with that, you can see the huge amount of infrastructure that would be needed for education, especially in states in the Midwest and in the South, where there's a huge amount of manufacturing and business need, but the educational programs aren't as concentrated as they are on the coast. And we can talk about all of these things later in the Q&A. I'm going to kind of go through an overview way. So one grant that I'm the PI for is this Keeping Data Science Broad initiative, which is looking at gaining where are some of these programs and how are they thriving at non-R1 places, places that are more teaching-focused, community colleges, minority-serving institutions, because we know that workforce actually is predominantly being trained at these types of institutions, liberal arts colleges, four-year colleges, where a lot more of our workforce is coming out of institutions that aren't necessarily research one. So we want to be sure there's capacity there. So this was a webinar. You can view these on our YouTube channel at South Hub, and it's broad. It's over the whole nation. So there's people from the Midwest, from the West, from the South, looking at their programs. Also, one other thing that comes up a lot is not knowing what the industry actually needs and having that connection between industry and faculty. So this is a program that's PEPI that has run for the last 2 years, which is programs to empower partnerships with industry, where we've had faculty members. This is one of our 2016 fellows from LSU, early career faculty members, where they go for several weeks to work with the research team at a particular company. Because I get this chicken and egg a lot, where the faculty will say, I don't know what I can do with industry. If only they would share their data, I could tell you what I could do for you. But then the industry would say, well, I definitely cannot show you my data until you tell me exactly how you'll make $1 billion idea for us. So this is a way to kind of get around that chicken and egg, where you can see the data from the inside. And 100% of these faculty members actually want to continue their research relationship into the future with that industry partner. This is also one that's data science extension, which is being led by the chair of computer science at Spelman College, Brandeis Marshall, who's here. And it's really about taking faculty members who are in the Spelman and Morehouse College, which are both historically Black colleges, four-year institutions, and in training them up in data science so that they can incorporate it into their current courses. So not necessarily creating data science courses, but incorporating them into the courses they're currently teaching. So there's 10 faculty. They did a 2-week training, and then for the next year, they'll be incorporating data science into their courses and staying together as a cohort. Another aspect of the Keeping Data Science Broad is looking at alternative ways of education through data science. So not necessarily the traditional academic programs, but looking at programs like the Breakfast Group, which is on the West, which is a mentoring program, which is started by industry to mentor high school students. And also looking at putting data science and arts and humanities courses, which Leor, who's in the Midwest, was a fantastic speaker for. Sarah Stone, who's a co-director for the West Hub, and talking about data science for social good, which I know you had Raid Gianni talking to you yesterday. Tracy Teal, who is director of data carpentry, which runs boot camps, data science boot camps, and then also museums. Stefan Uzo is the chief scientist for the New York Hall of Science, which does a lot of outreach for public data literacy and how to increase that among the general population. So this year, Atlanta, we have a data science for social good program as well. So the South Hub sponsored the graduate student component of that, which was really helpful. I think you get a lot. The students gained a lot and really form a network, which you've heard about before. Also community engagement around a VITAL series, which I'm actually pretty proud of this acronym. I may be the DC in me where I love a good acronym, actually. So it's video, image, text, audio, and learning data, where it was a monthly webinar where each month we would just look at video data and bring in someone from industry, from academia, from different departments. For instance, the text mining one had someone from Career Builder looking at text mining and resumes, someone from the business school who was looking at text mining for executive language, how executives talk about different problems, and someone from urban planning that was looking at text mining for trying to decide which areas of the city to plan and where the best neighborhoods. as well as, looking at text mining in scientific domains and in healthcare for medical records. So it was interesting, the techniques were different in the different fields, even though some of them were trying to do the same things. And so that education, kind of cross-education, really helped, because some people thought, oh, I didn't know they had solved that in that field, and I'm trying to do this. Maybe I can use these same techniques where I am. So lastly, there's some new programs that we're looking at trying to do this year, which are two. One is called SnapDS, which is stimulating new applications and projects in data science. So it's a little bit about what Chaitan was talking about, where we want to facilitate planning grants as well as the ability for people to collect and convene data. So not necessarily data gathering, but more data synergies. So if there are different places with data and they want to convene, we're producing travel support so that small groups can get together in conjunction with scientific meetings or current conferences to do some of these planning activities and to produce more of a streamlined document where they could be applications for spokes. And then just recently, part of receiving another grant, which the lead is going to be Kevin Stosson from Vanderbilt for NSF Includes, which is looking at creating a pipeline for retention of students in the physical sciences and engineering, which has been historically not as diverse. My original degree is in physics, and that is usually not a field that has a strong diversity in women or underrepresented minorities. So kind of creating a pipeline through those processes. So I'm going to stop here in terms of time to get it at exactly 10 minutes. But if there's any questions, please feel free to ask in the Q&A. And if you want to be involved in these activities, you can see that a lot of them aren't just in the South. There's been a lot of participation from the Midwest. Melissa has been great. So I would encourage you to reach out to her if you're interested in this or in projects you think may be complementary. And she can definitely connect you with me as well as some of the things that are going on. And so my email is here if you want to also reach out directly. Thank you.
Hello, my name is David Mongeau. I'm at The Ohio State University, where I co-lead, like Renata, co-lead an effort, but as our Institute for Data Science and Analytics, which we refer to as Translational Data Science and Analytics. And I'll say a little bit about that word in a couple minutes. So my introduction to data was in the, I'll try to be shorter. Is this better? Okay. To data was actually in the 1980s at Carnegie Mellon University, where I minored in data analysis. I wanted to be an English major, which I was, but realized that there was some value in understanding quantitative approaches to problem solving. And then I worked at Bell Labs for quite some time, and it's interesting, isn't it, that a lot of times we'll hear people say that big data, data science is not new, and I tend to agree with that. It's just evolved and become something different than it was before. But when AT&T went through divestiture and trivestiture, a huge issue was data mining and data cleansing of all the subscriber records. The government decides to break something up without thinking about, well, how are we actually going to manage all these huge information systems that are behind the telecom network? But I have to give a disclaimer from my work at Bell Labs, and that is I got involved in education and training, and there was a view that as AT&T had to become more competitive, that engineers needed to understand competition better. So I worked on a course about competitive engineering, which focused on benchmarking, competitive intelligence, and reverse engineering. And our targets around experiential learning exercises were how to beat Alcatel and Nokia. Well, unfortunately, take what I say with a grain of salt, because the outcome was Alcatel and Nokia bought us. So. The Translational Data Analytics Institute at Ohio State. It's a long-term commitment that we have with a big focus on solution development and talent development. I'm not going to spend a whole lot of time describing the Institute. I'm going to focus on one aspect of what we're doing, which is our looking at the university-wide educational investment. And in that activity, just so you have a sense of our orientation at the university around the education, we've bought into this notion of translational data science. We heard the NSF about the workshop earlier. Well, in 2014, we started to talk about this whole notion of should we focus on the aspect as a land-grant university of being able to translate our science to have societal impact and practical importance. And while we don't do that to the exclusion of foundational sciences of math, stats, comp sci, for example, we are very much focused on can what we're teaching lead a student to create a solution to a problem that matters. So in the abstract for today, there's a mention of a case study. And I'm going to talk a bit about our case study and about how we're approaching this one aspect of what the Institute is charged to do, which is looking at the university-wide educational investment. And what we're doing, in some ways, as I share, my background is out of industry, and the idea at Ohio State was, can we combine somebody, can we bring a faculty leader with somebody from industry, and maybe there's some positive interactions, maybe there are some tensions that could lead to a different kind of solution that we're developing. So in the educational investment space, we took somewhat adopting ideas of product development, portfolio management concepts to think about how we're managing this investment in data science education. So 2 years ago, we, like many large universities, we didn't even have a handle on what was available. We knew we had one of the first undergraduate majors in data analytics. We got a lot of attention for that, and that program has great success now with sophomores basically being placed in jobs. The competition is pretty fierce. So we did our own analysis, but then back to the work I did on reverse engineering, benchmarking, and competitive intelligence. I guess I'm a slow learner because that didn't turn out too well. We also looked at how we can get more information. So we work with the Business Higher Education Forum, EduVentures, and local economic development groups to make sure that we didn't have an insular view of what was needed in the space of education going forward. And we developed a report, which we then shared in faculty and student listening sessions, very much believing that if the university is going to have an impact on data science and analytics, it has to be well understood. And we have to listen to the voices of the students who are seeking jobs, the faculty that are helping them get there, or students who are seeking to do advanced research and the faculty that are supporting them in that. And that brought to bear this idea of you can preserve, that I also took from Bell Labs, you can preserve the integrity of the lab while providing a product execution. One of the takeaways I think that's important from our discussion today, and we saw this a bit from what Renata talked about, there is so much need that there's place for everybody to play, all the educational institutions and industry working together. And we don't have to sacrifice academic integrity by getting involved in the areas of training and workforce development. I don't think the large R1 universities can just think of, well, that's the job of the community college. That's a job maybe of an R3 local school. And we heard some of that earlier, and I think that's something that should inspire us because, again, there's plenty of room for all of us to play. So the three pieces of our looking at what we were doing at Ohio State and what we might need to do next. We determined through our internal assessment that we had 21 degree programs and 9 minors that somehow touched data science and analytics, including the undergrad major that I mentioned. And we're probably behind many of the other universities in the room in terms of certificate education, but we're increasing in that space. And the report led us to think about what else we wanted to do, and as you can see, the undergraduate degree is quite nimble. So while it's focused on interdisciplinary work, it also very much has a focus on industry segments and industry problems. So while we had a biomedical and a business and computational science track, we're now introducing social analytics and visual analytic tracks. And that is one way to keep attracting students by providing different tracks for them. But we also realized in some of the work that we see in the next two reports I'll share that we needed more graduate education. And I'm going to talk specifically about what we're doing around a professional science master's. So that was our internal scan. The second piece was we participated with the Business Higher Education Forum in Washington, D.C. and PricewaterhouseCoopers to look at the whole issue of national talent development for two types of positions, data science jobs and data analytics jobs. The professional science masters that we're looking at is focused on these analytics-enabled jobs. And some of the guidance in this report is that a good way for industry and university to come together is to invest together in market-driven programs, and also to find a mission that matters together. So it's very interesting to me that we could have, like all university industry, you get together, you talk about the great things you could do together around talent. But then when we started to say to local firms in Columbus that also care about some of the things we heard yesterday, local firms that care about, they want to contribute to stopping the opioid epidemic. They want to contribute to improving infant mortality because they'd love a headline that says Company A in Ohio State helped solve this problem by bringing data science and analytics to bear. So finding that mission space is something that I think all of us can learn by looking at who sits around us where we're educating, what companies sit around us. These are the 8 findings in the report. A couple things about them. I'm probably going to skip in the interest of time. You can I can give you a link to the report if you were to contact me. But it appeals to things we should both do in business and in higher ed. A big piece of this is why I say we all have a chance to play is if we looked at what Ohio State is able to produce today out of those 21 programs and 9 minors, you can see the numbers on the chart that show how many students we're producing. Well, this is the demand side of the equation. So just in Ohio, 81,000 jobs that were calling for data analytics and data science capability, and just in Columbus metro region, 13,000. EduVenture analysis showed something that's really pertinent to the Midwest Big Data Hub. The demand in the Midwest region is growing 3 times faster than the number of programs that are coming out. So Renata showed us a lot of programs, but this is saying there's need for more. So our approach with the business, we had the faculty roundtables, the student roundtable. We had these external sources that we tried to use to inform our work. And then we brought in the experts. This was something that was brought up yesterday during the keynote, that don't just jump to implementation, have a conversation with the stakeholders. So we brought in experts, we talked about design. All these firms have some sort of local presence, whether they're headquartered or not in Ohio, in the Columbus region. And we also thought it was important to bring into the room a behemoth like Cardinal Health, one of the Fortune 10 firms, with a Cover My Meds, a very successful startup. So we're going to hear differing points of view focused on this data analytics-enabled professional. We were not on this degree trying to develop data scientists. So our approach going forward, what did we hear from these firms? Experiential learning component to a degree is not sufficient. In the PSM, the basic message was, can't you work with us to come up with an experiential learning program? Not that we offer a capstone, not that we do a project in the last semester. What can we do that the entire program is linking the firm with the university? Second was not one course in problem thinking and critical thinking, but how do you underline all the courses to cultivate curiosity and critical thinking? How are all the faculty supposed to stimulate that in whatever discipline they're teaching? that led us to an idea of having, and this goes back to, say, the product development approach to curriculum, a controlled introduction. Very common in industry. Before you go out there, test it. So we're talking to some of these firms trying to find the win-win. If you invest with us, back to the BHEF report, looking at how to invest together, if you invest in this university and you identify students in your company that we can put through this program over the next 2 years, let's find a group of companies that want to do that before we open this up broadly. And let's iterate on the curriculum and be more responsive to needs. And then another hurdle that we constantly hear about is, but what about data sharing? If you do this controlled introduction approach, you have these students connected with a particular company, taking their experiential learning with the company. We have this notion of bring your own data. We don't have to overcome, well, how are we going to set up a VPN? How are we going to do these things? Those students are likewise interns or so on with the company, and that helps solve part of the problem. So these are some of the things we're doing at Ohio State. And the final point that I want to note is something else that came up in the past 2 days and last week at another conference. In addition to part of what supports talent is having a place. Just like us joining here to talk together today, we've heard time and again, if industry and students and faculty had a place to work together. So we have the benefit at Ohio State that we have that place, but that's something that we could all do to contribute further to data science and analytics education. Thank you.
All right, try not to look at this chart for a second. I know, it's kind of hard not to look at, huh? My name's Jim Barkley, and I moved to Chicago about 2 years ago from the Boston region to work at one of now 13 national manufacturing institutes in the Chicago area called DMDII. And it's housed by a nonprofit that focuses on public-private partnerships. And so I have a little bit of a manufacturing flavor to some of my thoughts. But just recently, as I was there over the last couple of years, I realized how dramatic the talent gap is, especially in the Midwest, at least compared to some of the areas in the coasts. And so I've recently just started my own company to try and address some of those. So that's where I'm coming from. I don't have too many slides, just enough to be provocative, I hope. Data science is not new. I'm glad you said that because that was where I was going to start. But economists have been doing data analysis for a long time. Back in the 90s, I worked with the National Oceanic and Atmospheric Administration. This is a group of scientists that are really profoundly excellent data scientists. And going on before that, all of the things that happened at Bell Labs, World War II had some really fascinating data challenges. So, it's not a new space. But what is new is the explosion of data. And now you can look at this chart. So this is, has anybody seen this before? Hands? Okay, a couple of people. Well, it's really the availability of data that's changed. Back in the old days, you had to design an experiment just to collect the right data. And the time cycles for doing data analysis were very long, and that was part of the reason. Sometimes that's still necessary, but it's much more common now to be overwhelmed with data and try and figure out what to do with it and make sense of it. And that's what this IoT thing is all about. We have decided to instrument every aspect of our physical and virtual worlds. And that's what we're trying to do today. It's transforming a variety of different verticals. That's kind of up at the top. But it's also creating a whole bunch of new startups and innovators that are really data companies, if you think about it. Yeah, and if you're a Kurzweilian subscriber, and I tend to be, really we're learning how to augment our evolution and our environment, the evolution of our environment with our technology, from Fitbits to smart cities, right? And this is giving rise to the demand for more data scientists. But saying we need more data scientists is the wrong question, in my opinion. That's like saying we need more doctors. You know, the doctor shortage in the 1960s was not addressed by more doctors. It was addressed through fundamentally rethinking how we administer care and what those regimes look like. And, you know, the nurse practitioner was born out of that, and other things like that. And that's really where we're at with data science today, in my opinion. This is the kind of workforce revolution that we're seeing. The demand is outpacing the supply pretty radically, and I think it's projected to be one of the biggest skills gap in the next 20 years, along with cybersecurity and some other flavors of engineering. So what does that look like? Well, this is an example of how we're kind of rethinking that whole landscape. So this, yes, I know, it's another eye chart, but I'll walk you through it. This is some work that came out of the Digital Manufacturing and Design Innovation Institute. They have a workforce development component at UI Labs out in Chicago, and they worked with a company called the Manpower Group to think about what are the next generation of manufacturing jobs going to look like. So there's about 165 different roles defined across some of these key areas, things like digital thread, digital enterprise. Many of these have a data science kind of component to them. There's a well over 100-page report on this at uilabs.org on the website if you want to hear more. But one of the interesting things is that a lot of the roles defined are things like collaborative robot specialist or enterprise digital ethicist or predictive supply networks engineer, right? And so these are almost specializations of data science, which get really interesting. And the World Economic Forum estimates that by 2020, about a third of, and let me just read this quote because I don't want to get it wrong, about a third of in-demand skill sets in most fields will require skills that aren't considered essential to that job today. So that's less than 3 years away, and jobs that are considered essential for, skills that are considered essential for a third of jobs today are not going to be relevant. Pretty fascinating. And that's from the World Economic Forum. Now, if you look at the kind of paradoxical nature of this, that's really interesting to me, this need for specialization and diversification is really rapidly expanding, but also the need for convergence and integration, right? And this is something that we see in biology too, actually, right? Diversity of the species and everything leads to advantages, but then also integrating those things into a symbiotic ecosystem, or an ecosystem which has patterns of symbiosis, is equally as powerful as an evolutionary force. And so, people entering the workforce should think about if they want to be specialized or if they want to be more of a generalist playing some of those integrator roles. But I think that's a big trend we're seeing. So that's all on the kind of the demand side. On the supply side, this effort at DMDII was paired with a set of open courseware partnering with Coursera to do a series of digital manufacturing and design modules. And if you complete all of those modules, you'll be awarded a digital manufacturing and design certificate. And this is a trend we're seeing more and more as well. You can head over to Udacity and get yourself a nano degree in data science, which I think is a couple of 2 or 3 month modules. And so people are starting to rethink how we can think about what the fundamental nature of work is, what qualifications people need. The other one, though, is that people have, the data scientists that are out there, the tool builders, they're also building tools to be able to do their jobs faster and better. And so, the nature of work is changing, the nature of education is changing, but our relationship with our technology is also changing, and it's evolving into a partnership of symbiotic capacity, which in my opinion is really one of the only ways that we're going to be able to scale to meet the demand in the next 2 decades. So that's it. Let's get to some Q&A.
Great, thank you very much. So, meanwhile, my question to all the panelists is, as I mentioned at the beginning, I'm in charge of a new degree, and I went round talking to a few employers saying, you know, what do you want? What should I be teaching in this new Master of Science in Information Management to improve the chances of my students getting a job? And this is obviously very ad hoc, you're the experts, but one thing that popped up time and again were answers that were sort of big picture. So employers would say things like, well, they obviously have to have the data analytics skills, but they also then have to turn those results into actionable results and explain things to our senior management who are not data scientists. So, you know, it's necessary to have the analytics skills, but it's not sufficient. So I put it to you panelists who've done this much more than my little ad hoc sample, are there other kinds of things that employers are saying they want that sort of fit in this big picture setting? And I'll start off with one of the people in the room, and then hopefully I haven't totally broken it and we can bring Renata back. Okay, you've got it.
So hearing two things I pointed out for the professional science masters that we're hearing are not novel or unheard of before. One is the importance of experiential learning, and the second is this notion of critical thinking. I think what's novel, though, is what industry is saying. Again, I mentioned, we don't want a course in critical thinking. We want critical thinking to be a unifying theme across the entire set of courses that make up this degree. And similarly, experiential learning, not to just be a project at the end of the degree. In terms of the other thing that we've heard very much, and I think we all buy into, is the notion of storytelling. We've heard time and again, and storytelling is part of the undergraduate degree program, that what we hear is if you can't understand what's driving the C-suite and how to make them understand what you discovered and why it's relevant, and in turn educate the C-suite to ask the tough questions, then we're not going to have the impact that we'd like to have.
I don't think we've got Renata back yet, so on to you.
Yeah, I think that's pretty well said. I mean, experiential learning is something we hear a lot at from employers. The last piece, though, that you mentioned, I'll just reinforce. I think it's really critical to educate the C-suite as well. It's it's true that communication of results is really critical and can be very difficult. But at the same time, I would also challenge business leaders to expand their thinking and understand some of the fundamentals of statistics and analytics, because if you're a company today, you're probably a technology company in one way or another.
We have a
Yeah, so I'm Carl Schmidt from Valparaiso University, since I haven't introduced myself earlier on questions. Mike and I were talking a lot about some of these things, and I have a sort of similar question, but perhaps phrased in a different way and getting at a different piece.
You will now be placed into conference.
Sorry.
To mute your line, press *6. To unmute, press #6.
Okay, we should hear you now. Yeah.
Do we have Renata?
Hello? Yes.
Hey, she's back. Great. Okay, perfect. Now this will go to everyone. Awesome.
Okay.
Certainly what the landscape for education looked like over the last couple years, and certainly employment, was that companies seem to want people to hit the ground running right away as soon as they hired them and be able to give sort of insight and things. And regardless of what that desire might be, we all sort of know that the scope is changing and that there's going to be entrances of people that are not already coming in with a bunch of experience in addition to the analytics knowledge and skills. My question, though, is from your experience or from your investigations with companies and from looking at, especially for David, for you, for generating this sort of landscape entirely at Ohio State, where do we draw the line in education between things that say we've prepared a student as well as we can to go out to a job, and then the company is going to pick up the training for specialization, or, and I mean, this could be at I would prefer not a mile high view, but it could be there where, I mean, we could talk about things like how deep into techniques should we really be teaching students, because depending upon your industry, the techniques that you use are going to be very different, but there are obviously some very core techniques that perhaps we should say every data scientist should know. So can you guys talk a little bit about where the educational programs should sort of help students land in terms of skills and expectations of where industry might then be picking up training levels? Or do you guys understand what I'm asking about at least? It's not well articulated.
I'll call on Renata to answer that. And while she's thinking, let me apologize for wrecking this and note, here's a little usability lesson for you. I teach UX design. Why did this go wrong? Because I was trying to talk, attend to the audience, and deal with technology all at the same time. And technology that's optimized, if you're only concentrating on the technology, is just fine. But I was cognitively impaired because I was mostly looking at you guys. And that's why I broke it. And that's why you need to test things in the real context of use. Anyway, little usability lesson. Back to Renata to answer the question.
Yeah, thanks, Mike. No, I completely understand that. We read a lot of webinars. It's cognitive dissonance. But to answer your question, or the question of the that was just posed about industry and kind of the line around academia, I would say, well, this is not a solved question. I don't think it's solved. But one thing that does come up a lot is, as before I got cut off, with communication skills and turning them into action. And one thing that I try to encourage companies to think about, instead of data talent, of thinking about the one unicorn person that can do it all, is that they really are going to have to hire teams. And students are going to have to learn how to work to get jobs done in a team format. Because, as you say, it's not feasible unless you keep students for 5 or 6 years to train them on every single technique. And even if you do, they're changing and emerging and new. And then you have to keep retraining your faculty to change on every single new technique that comes out and how to best use it. And that's a huge cycle of continuing education that we don't have in every discipline. And we certainly don't have the infrastructure in place for that now. But there are certain things that come up a lot, which are this ability to turn it into actionable insight, which really requires a deep knowledge of the domain, which is something we're not teaching in the data analytics, because we don't have the expertise in every possible domain to know which pieces will be actionable. So I think that critical thinking piece is really, really key, because you need to be able to say, this is a broad scope of the different techniques that are out there, and these are kind of the good and bad of them, and maybe evaluating, having some position where people evaluate what is the best technique for this type of problem. How can I work with a domain expert that doesn't have these analytic skills to try to explain that? And how can I work with someone who has a deeper knowledge of the actual technique to implement it? So at least those three components are necessary, and we're trying to find them and house them all in the same people, and not really giving people the skills to say, this is your piece of the puzzle, but this is just my own personal disclaimer opinion, but this is your piece of the puzzle, and part of our training is teaching you how to work with these other two pieces. And I think that's much more effective in reality, because of the different, very vastly different skill sets that are needed for those things. And also trying to line that up with expectations from industry, I think it's also difficult, because they're thinking all of those should be in one person, and we should be able to rely on them to do that, which you can, but then you have this huge shortage.
The panelists? Two points to the question. One is, having the conversation with industry. So Ohio State and IBM pursued a grant opportunity together, where we tried to say, where do we draw the line between education and job training? And try and figure that out together, and take it from an economic argument. How can we make this the most economically efficient university course and workforce training? So that was one thing. Second is, at universities that are fortunate enough to have a center or institute of some sort that goes across colleges, we think we don't want to dictate what the master's in applied stats feels is absolutely necessary to graduate with that degree. So the Institute's filling a gap by saying, but you know what? We're hearing from industry that they wish some students could come out who understood analytics at the edge. So we'll partner with an industry player to develop a program that gives the student choice to show up on a Saturday and try and get this short course or certificate even. So that's one way to start addressing these issues, is complement the degree programs with other things.
Anything you want to add? Okay, I have a question over here.
Thank you, Dan Linthel, University of Nebraska. So this is directed to, I forget your name, I'm sorry, Ohio State, and I'm an alum, so that's pathetic, but I apologize for that. Is there an intention to have this data analytics major be accredited in any shape or form? And if yes, what could that do? And I'm bringing this up because in my field in engineering, we're all accredited. We just finished our, the group is ABET, and that's a 4-letter word. We just finished it up, and my bias-dependent accreditation stymies innovation. So I was just curious if you had any.
So initially for the PSM, we, of course, will go through the review by the Ohio Department of Education. And then secondly, PSM degrees in the U.S. have to pass a review by a professional association, the PSM. So we'll do those 2 steps initially as a validation of content.
So I'll just chip in and then pass over to Renata. So ours is a new master's degree. We've chosen not to explore any kind of accreditation at this stage, precisely for the reasons you raised, that we want to be constantly innovating because we're learning as we go. We market it to our students. This is a startup degree, so we'll get things wrong. We'll move fast, break things, discover this. We have a long history with our other flagship degree, the Master of Science in Library Information Science, which is accredited by the American Library Association. That affords us huge credibility. Students can get jobs with that accreditation, but there is an inclination for a break on innovation. And sometimes it's not even the accrediting body's fault. It's people say, oh, we daren't do that because the ALA might not like it. We haven't even asked them, so there's that fear of what the accreditors will do is, one of the bigger issues. So I would, if there's going to be accreditation, it needs to allow for rapid innovation within some sort of framework of, is what you're doing broadly okay. I'll pass over to Renata. Any information on the various things that you've seen on issues around accreditation?
So I can speak probably to the Georgia Tech accreditation. So we have several programs, a couple masters and certificate programs, a master's in science and analytics, business analytics, and computational genomics, these other things. And some of them have been accredited for the reasons that you say. And there's one that hasn't been because of the fact that they're really doing a lot of innovating with an industry advisory board. And so some of the tracks change as well as the focuses change from year to year as partners are developed. So I see the flexibility as being an issue, as you said, for accreditation, but also it's really important to, if you don't have if you choose to go the non-accredited route, is that you really have a strong tie to workforce, because that way it's a direct link. These are the companies that are a part of our executive board. These are the ones that have been there with us from the curriculum development side, and they're the ones that are going to have a vested interest in these students. So there's no disadvantage to the students. And in fact, we see that, so there's 100% employment rate at the end of that program.
Any other questions? Please put your hand up. I am going to raise another one with our panelists, which is helping actual students and prospective students understand what is data science really. So I've found with some of our existing students, they come in, they've heard about big data, they want one of these jobs, it pays lots of money, and their impression is, I need to learn Hadoop. If I learn Hadoop, I can get a job, that's all I need. Why are you making me learn all that other stuff? Is it just because you do research on it? So we have students in the program who are very excited about learning things that they believe will help them and are somewhat skeptical about things that they don't believe will help them. But then the flip side is I think there are other prospective students who don't apply to study with us because their stereotype of what they think data science is doesn't match their interests. And I think, no, you're wrong. Data science is that thing that you're interested in and not that thing that you think we do. So misconceptions both of students we've got and students we haven't got but we'd like. Start off with somebody here.
Sure, I'll start. I think it helps. It's a big space, and I think it helps to provide people with some frameworks to understand that space and figure out where they want to play in that space. A lot of people think data science is, you're a hacker, you're a coder, and I don't like coding. Other people just want to be doing the pure math. Other people are the coders, but they are worried they don't have the statistics background. And then there's the technology side of it. And I think it was IBM that put out this really great map of kind of data storage platforms. And it talks about, it's got NoSQL and more traditional relational systems and then how those are evolving. And it kind of paints that full picture about where Hadoop fits in to that overall evolution of the technology to support the business outcomes that people are trying to affect. And sharing that with people just gives them some bootstraps that they need to help navigate where they can fit in terms of that space. And maybe they don't need to know it all, but it's not because it's irrelevant. Maybe it's just because their interests gravitate them towards something a little different.
Renata, do you have something you want to share on this topic?
Sure. I think that's a great idea of giving a landscape, showing where different pieces fit in. I was going to also say bringing in speakers from particular industries or people that can do that for the students, because I think that would be helpful in framing it. We find also that a lot of the students they come into especially places like tech, and they think, okay, this is what I'm going to work for Google. I'm going to work for Google and Yahoo, Microsoft, IBM, Intel, and that's my ambition here. And they don't think about the manufacturing jobs. They don't think about the healthcare companies. They don't think about those as viable options, and they sometimes don't pursue them for those same reasons. So we also try and bring in different industries to get a sense that, there are the same amount of interesting problems, technical rigor, groups and cohorts in these other types of areas that aren't going to be what they see, even if it's not Hadoop, what they see as data science companies that are really doing things and moving and shaking in this field. So I say that. And then also the new students, bringing in ones that don't apply is a little bit of a harder thing, and that's something that's a part of kind of the keeping the data science broad, this idea of bringing the data science to them. So putting it in the arts and humanities classes, putting it in the communications classes, taking it more into the fields where you would want more people to apply, and into those avenues in order to try and change some perceptions there, or at least dispel some fear that I don't need to necessarily sign up for a data science course. I can sign up for Introduction to Psychology and get, text mining or visual analytics as part of it.
Great. Thank you. David?
Two quick things. One way to deal with the students to help them understand is reach back into K through 12. So we, for example, will have a program about women in data science and find some meaningful activities in summer programs so students can become used to what this even means. Second thing is let students tell students. So a lot of times a student doesn't want to hear from a faculty member. They can identify more with somebody 3 years older than them. And we have a very large student big data analytics association. putting those students in front of the K through 12s and also in front of other students at the university is a good way to help people understand what they can do.
So within our departments across campus, there are different interpretations of what data analytics and big data means. In the context of education and trying to show what it can do, we have the same problem as we have with workforce, in that, you know, if you train us, then we'll show you what we can do with the data. But within departments, it's an even bigger issue because they're the ones who have to approve those certificate programs, those courses, and there's a bit of education that needs to happen within those departments. I was wondering if the panels have insights in how to engage and how to maybe speed up that process of educating our own peers about these methods.
So the challenge of explaining what data analytics is to our own peers in our institutions. Anybody want to? David?
I would just like to thank my colleague from Ohio State for giving me a homework assignment about this, because I don't have a ready answer.
Renata?
Yeah, I'll chime in here. I would say that you hit upon something critical. And just expanding the doctor analogy that was there, where doctors can sometimes be the worst patients, faculty can sometimes be the hardest sell for data science, just because they're experts. We're experts. You know your field, you know what's necessary, you've been doing it, and you really don't see why this is different, than the data analysis you've been doing in the past. So sometimes it's always good to have peers, just like with students, to have faculty that have done it or departments that have done it and showcase those successes to your peers, because then it kind of builds a little bit of the competitive spirit, in a sense that, okay, they're doing it there, they're having a lot of success, they're having a lot of student engagement, and it's something that we definitely have the capacity for, and I can see it. So some of that is also helpful. Again, I don't have a silver bullet for this question at all. This is something we do have to work with.
Yeah, I'll just add, it is very difficult. I mean, it's a big amorphous blob, sort of like cybersecurity, right? And it's emerging, and so there's not a lot of standardization of language or even, organizations around it. But that'll change over time, and who knows, maybe one day it'll even have its own, NAICS code.
Okay, well, I'd like to thank all three of our panelists for their insights. And if you want to ask them any other questions, come down here after some final announcements from Melissa. So if we can give a round of applause to our panelists, please.
Okay, so I just have a couple of wrap-up things. So first of all, thank you everyone for coming. I think this has been a tremendous meeting. I hope all of you have found some value in attending in person, and I hope the folks watching elsewhere have enjoyed the program and content as well. I want to thank the Kiewit Corporation for hosting us. This is a tremendous space. And the support for the AV and IT has been great as well, and we're really appreciative of this new potential partnership as it's developing, and the contributions they've made to host us this week. So thank you very much. Additionally, I would like to ask that please, if you're able to fill out your evaluation forms. This is really helpful for us in thinking about how we're scoping our work. It's an opportunity for you to give voice to ideas and areas you think we should be focused on, and the work we should be doing more broadly, and ways we can connect to additional partners and collaborators. So please fill that out if you will. There are blanks if you've misplaced it. We have extra ones out back. I want to thank the team on the ground here in Omaha and from Lincoln. Thanks so much for your contributions and support, and the work in helping us put this together. And of course, the team from the Midwest Big Data Hub. So thank you, and we'll see you next year.